Okay, welcome to the second of our series of cybersecurity panelist talks. We have a good panel for you tonight, and this is also being recorded. We're also being co-sponsored by several other affiliate chapters, student branches, and other societies within IEEE. Tonight's talk will be on the SBOM and its importance to software delivery and security of delivered software. And with that, I'd like to introduce our panel. So I'd like to go ahead and start with Professor Camp or Allan. Okay, we'll start with Allan.
The only slightly disappointing student from Professor Camp's. So my name's Allan Friedman. I'm known as the guy who doesn't shut up about SBOM. I've been pioneering the government effort to create a community around it and turn what started off as a pretty good, if somewhat unpopular idea into something that actually is a natural part of how we make and build all software on the planet.
Thank you, Allan. Professor Camp.
Oh, I am most honored and pleased to be have been Allan Friedman's advisor. I'm a fellow of the IEEE, of the ACM, and of the AAAS. I am also honored for that. I am very interested in the systematic and human elements of SBOM.
Thank you so much. And Tom.
I'm a consultant in cybersecurity, supply chain cybersecurity, and especially now in software supply chain security. And I've been participating in the NTIA efforts for more than 2 years, and then will be the current CISA efforts as well. And I'm a consultant. It's been my background is primarily in the power industry, especially with the NERC SIP standards. And I've been especially addressing SBOMs a lot in my blog, which is called very, very inventively Tom Alrich's blog. So, but I do a lot about SBOMs and VEXs in there too.
Thank you, Tom. And Steve, go ahead.
Steve, I do security test and evaluation in CISA for our internal applications, testing them from the development through the production side, looking at leveraging SBOMs to actually see what's in our infrastructure after we deploy, and have to look at them as new vulnerabilities arise and try to work with the project teams to remediate those.
Okay, thank you, Steve. So, and I myself am Johnny Johnson. I too work at CISA. I'm also the chair for the Richmond Computer Society of IEEE. And so with that being said, let's go ahead and get to our questions. So panelists, I guess the first question is fairly obvious. What is SBOM? So a lot of people probably don't know what SBOM is. So if each one of you could take turns and talk about the definition of SBOM, or just go ahead. Allan.
Sure. So on my shelf behind me, I've got a Twinkie. And if you go to the store and you buy a Twinkie, it will come with a list of ingredients. And the fundamental question behind software bill of materials is, why on earth do we expect more transparency from a non-biodegradable snack than we do from the software that runs our government, that runs our critical infrastructure, that runs our most important platforms? Now, the challenge, and we'll get into this today, I hope, is what those dependencies are and how we make sure that they're captured and measurable in a sustainable fashion that both meets the uniqueness of different corners of the software world, aerospace, chemical engineering, open source, and at the same time is broadly based enough so that you can take from one to the other, because of course we all use the same software, is a bit of a challenge. And hopefully we'll dive into that in the conversation.
Okay, Tom or Steve or Professor Camp, do you want to expound on that?
It's a pretty good answer. Alan's done that once or twice, I'll tell you. So I don't have too much to add to what he said.
The other thing, so a question I'll ask for you, Professor Camp, is why is this important? Why, for the audience members attending, why should SBOM be important to them?
SBOM is critically important to enable organizations to know if they are at risk. It is the data substrate that will allow you to be aware of what is happening in terms of your exposure on the network. The core of SBOM is a machine readable list of all the dependencies and the components. And right now, attackers are fairly able to get this information by testing and scanning, but law-abiding organizations who are trying to do something with their networks, not, just defend them, but actually get something done, don't necessarily have the capacity to do that. So the software bill of materials is, in terms of my research on it, the data substrate that enables a more transparent software market and more effective mitigation of vulnerabilities.
Sounds great. And Steve, I know we're mandated by executive order for this kind of thing. Do you want to add to that the importance of SBOM for the government?
I think the importance of SBOMs, specifically when we're talking about government and just in general critical infrastructure, any private entity, also private public entity, it lets you know what's there. And as software changes throughout the patching and everything, it's when you take a look at Log4j, finding out where Log4j was. I know from us in CISA, it took us publishing lists from on GitHub, just keep publishing and updating the list and trying to figure out where those all of that Log4j existed. SBOM helps you drill down and identify quickly and easier so then one, your network defenders can start looking at where they need to defend and how to put countermeasures in place. And your developers can in turn also go back and start remediating, finding out where they need to fix it or coming up with ways to fix it or see if they're actually vulnerable. If there's, in the case of Log4j, the initial issue was the JNDI, was that being called. So just it helps you quickly identify where there's potential issues.
And I want to sort of build on something that Gene said about it being a data substrate. Because the example that Steve just used said, okay, well, like if I have SBOMs and I can find it. Now you're going to have different use cases if you make software, right? I have dozens of products. Am I putting my customers at risk versus this is on my network versus we're about to buy something. So we're going to have different use cases. And the SBOM itself doesn't solve those problems. That's one of the things that I always want to make sure, right? The SB in SBOM does not stand for silver bullet. The challenge is it's very difficult to do any of the things we know we need to do without this data layer. So to beat our list of ingredients analogy, right? List of ingredients won't protect your family from allergens. It won't keep you on a diet. It won't allow you to have a plant-based lifestyle or follow a religious restriction. But good luck trying to do any of those things without the SBOM. So it's the data layer on which we're actively building things. And we can chat about how the community has grown. And if there's some entrepreneurs out there, some students out there, great opportunity.
Okay, thank you. So who's supposed to be using these SBOMs? Is it just the software development industry, or is it the IoT industry? Is it the embedded technology industry, the power industry? Tom, do you have any insights from the power industry on this?
Yeah, well, I mean, essentially, you've got two groups of users. One is people who produce software as, you know, as their primary business, and they are already widely using it. And so, in fact, there's one tool called Dependency Track, which utilizes SBOMs and then looks for vulnerabilities. And the developer of Dependency Track found out to his surprise that it's already generating just to one database 200 million queries every month. You know, just the number of, you know, the tens of thousands of instances that are out there. They're being very heavily used. They're being used almost entirely by suppliers. And so there's now the use case of end users, that is the energy industry, you know, the hospitality industry. I mean, everybody who uses software needs to use them and needs SBOMs, but they use it in a different way than the, you know, than the people who are providing it. The people who are actually providing the software use it, you know, they need to decide what components should be in their product and which ones shouldn't because they're too risky or something. And so they produce SBOMs multiple times a day, usually, for one product, you know, while they're building it, just to, so they know what's in there. And the end users have, you know, a different use case, but that's one that needs to be explored a lot more and is not currently too well addressed in terms of the, you know, the literature, I would say.
Thank you. And Allan, so as we deep dive a little bit into SBOMs, what's the things that should be included in a good SBOM or a typical SBOM, if you will?
All right. So whoever had Allan forgets to unmute himself in the IEEE pool wins the free round. So there's a temptation to want to put a whole bunch of stuff in an SBOM because you're like, hey, I've got one stack for all of my supply chain data. Let's just throw it all in there. And there's some folks that are building that. It's great for them. One of the challenges is if we think about it as just an AppSec model, right? So, you know, things, some of the tools out there are just for application security. That's fine, right? It's only going to be in your organization. If you're trying to build it as a supply chain tool, then we need to be careful about tracking things across. And so one of the things we've been advocating for is to say, let's have a fairly lightweight vision of your dependency graph, right? This calls on this library, which in turn calls on this library. And then we can link that data to other sources of data. Now, what should that data look like? Well, for each component, we don't need that much information. And in fact, the US government published last year what the minimum elements of an SBOM are. And we can talk about the regulatory side, which basically says, you know, for each component I talk about, who's the supplier, what's the product name, what's the version. And by the way, some folks are discovering all three of those are quite complex ideas that we've been debating for decades about how to define. And then where did this data come from, right? Who's the author? Did it come from an open source library? Did it come from a product vendor? Did it come from a third-party security company? So we don't need that much data, but we also need to sort of say, hey, it's got to be in a machine readable format. So Gene flagged that it's, you know, we need to be supporting automation. And so there are currently two popular widespread approaches, each with a pretty solid deployed user base. It'd be lovely if there was one standard. We've got two. And fortunately, you know what computers are good at is translating well-defined data. And so we're sort of helping those two communities work together.
So Professor Camp, I know you're in the academia circle. Is this going to have any kind of impact on AI technology and the AI and machine learning, deep learning?
Well, I think that clearly there are roles for AI in every step. As SBOM becomes popular, you are going to see, right now we're developing honest SBOMs. We're doing identification of components. The two standards that Allan talked about, they just read the code and they look for what is clearly called. But as SBOM becomes more popular and attackers, APTs start thinking about how to keep vulnerabilities invisible, we're going to need AI in generation and verification of SBOMs. But that is because, you know, security is an arms race. And the more SBOM brings to defense, the more it is going to be targeted. And then when we think about evaluations, as companies really adopt SBOMs, there will be the potential to map the degree to which one software package as opposed to another software package changes your entire system risk profile. Are you increasing significantly your attack surface? Did they do things in a very different way? And then in operations, integrating this with threat modeling, like Steve was saying, mapping a vulnerability to a service, not just to code, but to a service. Just because a dependency is there doesn't mean that you are necessarily using the service that is embedded with the dependency, or that it is a current, or is that a critical service. You don't necessarily want to shut things down. How will you mitigate that? I think that this SBOM brings forward some of the core issues in how do you have complementary human and artificial intelligence to generate risk mitigation.
Thank you so much. And Steve, I know we've been implementing tools around this. Is it possible that we could get to the point where we're generating SBOMs automatically through the CI/CD implementation?
I think that's probably where it's going to be the easiest to implement. Is there's already plugins available for a lot of the orchestration tools that are out there that the developers are technically already making SBOMs every time they build software via like the POM file or the lock file, like the package file for some of the other ones with PIP. They're already doing it. So it's all where can we now store it in one centralized format instead of all these different formats that are used to build. It's where can we store it all? Pipelines help to ease the burden because of automation, but we've already been doing it for decades with those types of files. So it's there. It's just the natural evolution to a new format that is more data centric, more machine usable. And as we look at more and more data, like the NIST NVD is just growing at an exponential rate with CVEs. I don't even want to fathom what number we're at today that's already reserved out there. But it's taking all of that data and now correlating. It's creating large data maps to look at what are the vulnerabilities out there, what am I using, where are the nexuses.
All right. And Tom, once again, for the embedded devices that you're shipping an appliance or a device, how would you incorporate any kind of automatic generation of SBOM, and where would you keep the SBOM if you're trying to link it to a embedded device, such as an appliance or something like that, a switch gear, a smart switch gear, or something of that nature?
I'll be honest, I'm probably not the right one to answer that question.
Hmm.
My guess is Allan might have a better answer, but maybe Steve and Gene would eat too as well. But I'll let them. They can do a much better job than I can.
Allan, Steve.
So there are a couple of questions sort of folded into that. One of them is, hey, how do we generate it? And is there anything unique about an embedded system? And part of it is to say, no, there isn't, right? I'd much rather debate which of our text editors is our favorite text editor and is superior, it's Emacs, then talk about the difference between firmware and software. There are differences, but for the purposes of supply chain tracking and vulnerability management, it really comes down to, did you write it or not? So if you're using a third-party source, whether it's in a UEFI or it's in some flashed firmware, the important thing is, where did it come from if it didn't come from that first supplier? So the next question is, hey, how do we move it? How do we track it around? And that's something that we're still working on. It's one of the sort of the big open questions in the community. Not unique to SBOM, but as we spend more and more time saying we need to track key metadata about software, we need to figure out how we're going to move it around. Now, if it's bits on a platter, that's easy. We just store it next to it. And yeah, they're going to be bulky, but modern applications are pretty large. In an embedded space, there are a couple of solutions, which one of them is MUD, Manufacturer Usage Descriptor. It's an IETF standard, which Gene has done a lot of work on. And there are some other solutions that basically involve pointers, references, or having third-party data tracking.
Okay, thank you. Gene?
I will say that I am in fact a fan of MUDs. That I think the manufacturing usage description, which the original goal of the MUD was to provide a permission-based access control list for simple IoT and embedded systems, where you're not going to have, public key capacity, you're not going to have tremendous additional capacity on the device. And a core component of that is the secure install, where you get a uniform resource locator that has this access control, but it's expandable. And now there is an IETF standard that integrates MUD and SBOM.
Thank you. Thank you so much. So we talked a little bit about standards, and there's a couple of different standards. So if we're dealing with several different standards and several different tools, having these multiple standards and formats, is it easy to do a lossless translation between the different formats? And I'll leave that open to any of the panelists that want to weigh in.
I would say, Johnny, there's a lot of universal converters going between the two different standards out there. So it's kind of like XML versus JSON today. They're both in the same type of format. I believe they're actually both in XML and JSON. But it's what version do you prefer? Do you want yours in SPDX, or do you want it in CycloneDX version? They probably both have their own pros and cons to each standard, but it's a standard, so they can be easily converted for the most part from one or the other. Or during the build process in CI/CD, you could generate both versions if you needed to.
Yeah.
It's going to partly depend on what's in the SBOM too, because if it's just the minimum elements, yeah, fine, there's no problem there. When you get to some of the other things that where one standard like SPDX has very good coverage of licensing issues, and CycloneDX is what they have is pretty much copied from SPDX. They're quite honest about that, but again, they don't cover that to the same degree. On the other hand, CycloneDX has, in my opinion, more capabilities in terms of vulnerability management than SPDX. So you're not always going to be able to make a clean copy between them. So you have to be careful about that. But in general, it's, yeah, you're right. It is. They are interoperable.
Okay. Thank you. So, and I guess we come down to the $64,000 question. So if we're listing a list of items that are built into software, could not that list be used by an attacker to help penetrate a device, if you will? Anyone on the panel?
Well, the point about it is the attackers can get in a SBOM whenever they want. It's not, they don't have to get it from the supplier or one of their customers or anything. They can generate one their own with with a binary analysis tool. So, so the point is the suppliers, the attackers, if they are really trying to penetrate a particular product, they're going to have an SBOM for it. What the defenders need, the people who have that product installed, they need to know what's in there so that they can defend it properly. And that's why they need the SBOM. So they're really, there's always this talk about roadmap for the attacker. Well, that's what we need, but the SBOMs are really a roadmap for the defender. And that's why it's really critical that they do get distributed.
Yeah, thank you.
So the one thing I'll say, if folks weren't, because Tom's absolutely right on that front. Listen,
there's a first for everything, Alan.
in 2022, we don't just talk about hackers. We don't just talk about bad guys. We threat model, and so you've got your advanced adversaries, and that very much fits into the category that Tom described. Right, Ghidra is free. Right, NSA made it public because they knew that being able to do reverse engineering is critical to the defender's job. On the other side of the attack spectrum, you've got automated malware, right? This is how ransomware attacks get a toehold. They're going after known exploits, and they're just automatically scanning. They're jumping into networks. They're using automatic scanning tools. And so there, as Tom was saying, the goal is to make sure that the defenders know what's on their network. Is it possible that there is some space in the middle where having these public could, enable one or two attackers to do something that they could otherwise not? Yeah, willing to entertain that. No one's convincingly sort of told me what those attackers like, but I'm willing to entertain. However, the vision is to say, one, we need to have the roadmap for the defender, and two, as a last resort, there's no guarantee that, or there's no requirement that SBOMs are going to be public. It's going to be much easier if suppliers make them public, but in a lot of industries, automotive, energy, oil and natural gas, we know that at the beginning, people are going to want to keep them public and only share them with their customers. And so, obviously, if you have 10,000 customers, it's kind of the functional equivalent of making it public. But these are not new arguments about sharing information. We went through this with vulnerability disclosure and things like that.
Okay. The other thing would be, how do we get people excited about this? How do we get people to want to create these things and manage these things? How do we get that human element to agree to do this?
I am going to do the academic thing here and argue from research. And that is, there's been a tremendous amount of human-centered research from Indiana, from Carnegie Mellon, from all across the globe, where people provide security, verifiable security information to consumers who are making a decision about software. And systematically, we find that if you provide security information, people will make more secure choices. So the SBOM is happening as part of the larger executive order. So if you can take, even at an industry specific level, I give an ISAC and just make the existence of an SBOM kind of the Energy Star, which is the label model that NIST picked. So if the existence of the SBOM becomes a part of the label, even if it's just in one ISAC that is providing the labels, and you start to get an advantage by providing that security information, then I think providers will become more excited about it because they have an incentive to do so. So right now, I don't think I'm saying something contentious when I say security has a lemons market problem, right? I mean, every product you buy is the most secure, the most excellent. Brian Krebs had an article about the cat card readers where the military compliant most secure CAT card reader had a requirement that you download a driver that included malware for data exfiltration in it, right? So if you had an SBOM for that system, that they would not, I'm just going to go out on a limb and say, if you had to have an SBOM, you're not going to include malware in that system and announce that, oh, I'm also, one of my dependencies is ransomware, right? So I think we are generally aware that there are chronic security issues, and there has not been a lot of trustworthy information. And since this is occurring with the labeling, I believe that there are, I believe in incentive alignment more than I believe in excitement, although excitement is the most fun. And customers and providers of quality goods both have strong incentives to adopt this. And I think so do ISACs, who could provide verification and queer, not just dependency track for different industries, understanding the needs of those industries. I'm optimistic.
Thank you. So let's take a question from the audience. So we've got an attendee asking, how is VEX going to help SBOM, and does it need to be a part of the SBOM? Are there any practical implementations of SBOM and VEX integrations? I'll leave that open to the whole panel.
So why don't I tell everyone who's not familiar what VEX is. Yeah. VEX is one of the worst named projects in all of InfoSec, and that's probably my fault. So it stands for the Vulnerability Exploitability Exchange. And if you sort of believe the mantra that there's nothing in the world so permanent as a temporary government program, this is a temporary name that we had given it. And of course, we kept talking about it for so long that we just said, we'll call it VEX. So what is a VEX? A VEX is actually something that can exist independently of SBOM, and it probably should be thought of as independent. It is a security advisory. At the end of the day, that's all it is. It's a way of saying, this is the status of this product. Now, the important difference is most security advisories say, I am affected by this vulnerability, right? You go and you ask, Siemens and Microsoft and everyone else, right? This is what's in the National Vulnerability Database. There's a bunch of links saying this product is affected. VEX can do that, but it can also do an even more important idea, which is to say, we're not affected. So my team had a very busy December helping manage the log4j vulnerability that Stephen mentioned. And this would have been really helpful if a vendor could easily say, at scale and in a machine readable fashion, we're not affected by log4j. We don't even use Java, right? We're built in C. Or yes, we're using log4j, but we've been inline control. Or hey, guess what? We're so bad that we're using log4j 1.3, and so we're 4 years out of date. So we're not affected by this vulnerability. All of those in the short run would have been helpful as organizations scrambled to understand what their risk was. Yeah. Now, they're very relevant, and the easiest way that I like to link them is to say, an SBOM gives you potential risk, right? This is in my product, and so you might be affected, and that's pretty easy to do, right? I look at my SBOM, I look at some list of known bad, and then I link them together. So SBOM turns on the dashboard warning lights. VEX allows you to turn them off if you trust who's telling it to you. Right? It could come from a security vendor. It could come from the supplier itself. And we're still working on exactly what that's going to look like. There are implementations today. There are companies that are offering VEXs. And it's being implemented right now in CycloneDX. And also, you want to sort of emphasize this in something called the Common Security Advisory Framework. It's not an InfoSec talk unless we're throwing around acronyms. The CSAF. Which is an attempt to make all security advisories machine readable. And this is something I'm going to give you a little teaser that CISA is going to be sort of working very hard to promote over the next few years.
Thank you, Alan.
Yeah, I mean, John, the motivator for VEX is the fact that, you mean for developing in the first place, is the fact that a very large percentage of component vulnerabilities, that is, you've got a list of components from your SBOM, you go to the NVD, you find a bunch of vulnerabilities that are applicable to those components. A very large percentage, like perhaps 90 to 95%, are not actually exploitable in the product for various reasons. So, you know, the point is, if you get this huge list of vulnerabilities in components, you're gonna say, oh my God, I've got to drop everything, you know, and mitigate all of them. And then you find out later that, you know, most of them were not exploitable anyway, and you completely wasted your time. You're not going to be too happy. And plus, if you then call up the supplier's phone lines and you're deluging them with, you know, inquiries about, well, when are you going to fix this vulnerability? Well, we don't have to because it's not exploitable, you know, and they say that 100 times a day. And so those are the things, that's what's really motivating it. It's really the suppliers, to be quite honest, who are most interested in getting that out there, because they're very worried about what will happen if users start pursuing every one of these vulnerabilities that are there, because most of them are not actually something they have to worry about.
Okay. Anyone else have any thoughts on VEX? We'll go on to the next question. This one's kind of an interesting question. So he says, as a embedded developer using C language, he has looked at header files that call another header file and gone 12 layers deep, going down that one rabbit hole for just one microcontroller. How big do the number of items get on a typical program? And I'll leave that open to the whole panel.
So they can get big, and that's part of why we need them. So one of the initial framings around SBOM, especially even a year ago, as we were trying to help organizations get comfortable with the idea of SBOMs, is to say, well, maybe you just need to have the top level dependencies with enough data so that everyone can recursively generate their way down this graph. So we're thinking of an SBOM as a tree. I've got my piece of software, it's top level dependencies. Each of those has dependencies and so on. That gets pretty big. XML, JSON, these are not super lightweight platforms. The challenge of just having that high level is, of course, when you're starting to deal with something like, I don't know, some of the TCP bugs that were found in the, oh God, I'm blanking on those names of all the Forescout and some of their teams found in IoT and industrial IoT bugs. Those are buried deep into the, Ripple 13.
No, amnesia.
Amnesia, thank you.
Right.
Right, these are buried deep in the supply chain. So you ultimately do need to have that list. So this is why when we're starting to talk about where do we move them, how do we put them, putting them, online in a queryable form or in a database in a queryable form is going to be much more valuable than trying to sort of tuck them into the embedded system. I'll flag that one of the other challenges around C is unlike, say, a modern application model, where you have package managers to help track all of your components. The C libraries, you may say, well, we use this C library, my team's always used it, and so we've got our internal name, right? We've been doing this for a decade. That may differ from what someone else calls that library, or what that library is referred to in a vulnerability database or a third-party risk analysis organization that's starting to try to track things. And so that's one of the challenges we have. No easy solutions for that piece, but it's one of those things that we try to flag, and we're slowly working on sort of converging towards it.
Okay, thank you. Go ahead.
I think that there is a reasonable hope that once SBOM becomes very widely adopted. I mean, I think its adoption has been remarkable for a security standard. Let's compare it to, you know, DNSSEC, right? I mean, the uptake has been truly remarkable. But if you look at how much you just default to include, you know, you include everything until it works. And then the package that you included everything until it works. So there has not been a lot of support for pruning dependencies, or, you know, in Android, like pruning permissions. So, you know, space is mostly cheap. So including a lot and making sure it works, as opposed to iteratively going through and deleting every dependency, is rational human behavior. But as we develop these tools to validate and verify SBOMs and dependencies trees, developers are going to get another level of support for their own coding and their own scoping.
Yeah, thank you so much. Once again, it's open to the audience for questions. Just type your questions in the question and answer box. And okay, we've got another question here. It says, many vendors provide patched versions of open source software with the same name and version as the upstream, and it may result in false positives. How can the SBOM handle this situation? And once again, I'll leave that open to the whole panel.
I would say, Johnny, it's one of those, SBOM is a tool, is a data. It's all data, and you still need to verify, like what Allan was saying, it's just an ingredient list. You need to go verify that it's actually still there, that you're actually vulnerable to it. So I don't really see how SBOM could create something new to handle all the different version changes that some of the vendors do, like backwards patching and whatnot. It's information that, hey, you may want to go look here for this. I would even add in, go ahead, Allan.
I was saying, this is, as Steve flagged, this is a really hard challenge. And in fact, right, for a while, there was an attempt to say, hey, backporting is not a best practice, and so we should try to get rid of it. Because, right, if I'm making a product and I download OpenSSL from a trusted repository and I make some changes to it, that's no longer OpenSSL. That's now Allan SSL, and I should have responsibility maintaining it. But that's not enough to sort of point out, because I still have all of the technical debt that was in the original OpenSSL. So hard problem. Both CycloneDX and SPDX are working on a way to say that this component has certain functional relationships to other entities, and that includes things like implements a formal standard, or right, is descended from this piece of code. But it gets tricky, and we're certainly pretty far from knowing exactly what the defender should do with that information, and sort of mapping that back to our defense tools.
And Johnny, I would even add more into that. So as you look at some of the software and libraries out there, like I know there's been a big, in the news lately, a lot of stuff with Python packages where they're intentionally malicious. It's when you look at someone what is actually a package in general may not be malicious or contain vulnerabilities in itself, but depending upon where you get it from, if it's from an adverse place, are there now intentional vulnerabilities in it that are not going to be caught normally, unless you break down that source code and review it yourself to look for the malicious code? It's where is it even coming from now at this point?
Good point. Good point.
It's like it's going back to Allan's reference of the dietary reference on the Twinkie. It's like where am I procuring the sugar from? Like, is it from the East or the West Coast at that point for some of these things?
Good point. Good point. So at this point, I think we need to go ahead and let each one of our panelists have their 2 minutes, and just whatever you think we need to know about, or the audience needs to know about SBOM, promote your blog, promote your programs, anything you need to do. We'll just go around and we'll start with Professor Camp.
Thank you. I do not have a blog or a SoundCloud to promote, but I will say I am immensely optimistic about SBOM because of the alignment with all of our incentives. But at the same time, I am cognizant of the inherent integration that will be necessary with artificial intelligence at every stage of the SBOM lifecycle. So the SBOM is a critically important data substrate. Like all other foundations, it has to be verifiable and trustworthy for progress to be made. So I think of it less as a food label and more as a building code, because you have to have foundations for buildings, but you're not going to tear down every pre-built building to reconstruct the foundation. So all of the difficulties in naming, in Allan SSL will exist for a while. But despite the very real risk, I think that without SBOM, I don't see how we're going to move forward without SBOM and labeling a more systematically secure network.
Thank you so much. Allan, go ahead.
So I'll flag two things very quickly. First is how this is actually one of the rare security pieces that helps, that works in the favor of small and medium-sized enterprises and newer enterprises, right? A lot of security regulations, you got to hire fancy consultants like Tom to sort of help you manage this. And that obviously has economies of scale, right? Much easier for a mega company to do it in small business. What's great is Steve mentioned that there are already tools that are built into CI/CD pipelines. There's a single line Docker command that will tell you what your SBOM is of a deployed container. So this is something that really helps small businesses. And the second is a plug first to join the public international cross-sector effort to sort of continue to refine, operationalize, and scale SBOM. I'll put an email of how you can get involved. And then the last thing is, if you're in the research world or you're contemplating starting a small business, there are a lot of open questions. And we need all the smart people, especially, if you've got experience in one part of computer security, one part of software development. There's a lot of green fields to build something or ask a hard question. So please come and join us.
Okay, thank you so much. And Tom?
Yeah, thanks, John. I was struck, well, earlier you asked about how do you get SBOMs starting to be used, really people, how do you get excited about them? And my feeling there is that actually Allan's NTIA did a wonderful job taking care of the suppliers. I mean, actually, the suppliers are using them now. It's not anything new, I mean, a lot of them aren't, and shame on them, but because it's so advantageous to them and they're convinced of that. So we have all this, well, if you build it, they will come. Well, if we build it, the suppliers build it, but the users aren't demanding it now because there's no, right now, there's very little written about how what you do with the SBOMs when you get them. And also there are very few tools available to actually use them to go out and look for vulnerabilities. So that's what, you've got it. You can only push on one end of the string so long before it just bunches up in the middle. You need someone pulling on the other end of the string to get the whole string to move. And right now we need to focus on the other end, which is the consumer side. And so that's how I think ultimately SBOMs will be widely used. It's because of, the consumers will demand them.
And Steve. Thank you, Tom. Steve?
I would say SBOM, it's a data set that we've been the developers have been looking at all the time. Now it's being publicized a lot more and getting a lot more attention. It's helping to shine the flashlight in the dark corners where instead of everything being lit up all at once or just little candles, it's shining the light into the corners to see this is where I need to focus my efforts, specifically when you're looking at the defender side. Where do I need to focus my efforts, or even with the development side, what should I be looking at? Is there an issue with something that I'm using that I need to look at using a different language, a different library, or should I be looking to upgrade based on the vulnerabilities? What can I upgrade to not have to do too much code change and churn? It's really shining the flashlight in those corners to see what it is and how can I fix those, and knowing what I'm actually using. Because there's a lot of times there's copy and paste code, or you're pulling in libraries that you may not know what they are, what they do, just inadvertently, and what's buried in that whole hierarchical structure of the SBOM. It shines that light, and then it allows you to, like Allan said, it's that dashboard with the in the car that has the alert light on it, and then you can slowly turn those lights off as you go through and troubleshoot things.
Thank you so much, Steve. So there's one last question, and that would be, what's next? Where do you get training in this, and how do you learn more about this? And I believe we have a slide that actually has some resources on it, Allan, that our viewers can go to learn more about SBOM. So we have government websites, CISA.gov, which where Steve, myself, and Allan all work. There's SBOM formats, SPDX.dev, CycloneDX.org. The Linux Foundation has a lot of good information about SBOM. I personally have taken the free SBOM course to learn more about it prior to this this talk. And one other last thing I'd like to mention is this is being put on by the Computer Society of the IEEE. So, you know, if you have any interest in joining the IEEE or learning more about the Computer Society or IEEE, please look up IEEE.org on the internet. And I believe that that's all I have, and we have 5 more minutes in case anyone would like to. I think we had one more question.
I was going to say, should we touch on the elephant in the room, which is the executive order and how government decided it's going to government?
Yes, we could definitely do that. I know that's near and dear to Steve, yourself, and myself's part, because we work for the government. So go ahead and talk about that.
So, you know, we talked a lot about motivation, making it easier and cheaper to produce SBOMs. Tom talked about the value of sort of tools that can consume it to drive the pull, and Gene talked about incentives. You know, one idea I had to make SBOM more popular is we made stickers, but you know that only goes so far. And what started off as a purely voluntary government effort, last year the White House said we want to move faster, and so the White House issued Executive Order 14028, which was the administration's response to a number of ongoing cybersecurity threats a little over a year ago. And one of the things that it requires that everything the US government buys has to have an SBOM. I'm assuming enough of our audience is in the broader DC and Beltway bandit area to know that, my goodness, the US government buys a lot of stuff. And Steve can tell stories about the quality of that stuff. The vision is to say, what does this look like? And so we've gone from the defining of an SBOM to now actually integrating this into rules that in the short run are going to come from OMB, just going to say, hey, if you're the CIO of an agency or a department, you got to ask for SBOMs, here's how. And that's going to be a little lighter weight. And then ultimately it's going to be integrated into something called the FAR, federal acquisition rules, which are a very big deal and really shape the course of massive amounts of technology.
Yes, they sure do. I can attest to that. So we do have another question about which is better out of the different formats for SBOM. And I don't know if one's better than the other. Do any of you guys have preferences on what the best or the, I guess it's kind of like VI versus Emacs, right? Or am I wrong about that? Open to the panelists, everybody.
Well, there are real differences. To say one's better than another really depends on your use case. And so, you know, if you can say what your use case is, then one might be better than the other. So, but they're both good and they're both very well supported. And so you won't go wrong with either one if you if that's your question.
There's a third case, right? So one is saying, hey, of the software that I'm looking at, pre-build, right? What's in the repo? And that's useful if you're trying to understand the broader risk across a portfolio. Then there's at time of build, and that's probably the closest to a certain type of truth about what's in the software, since the compiler and the build process actually sees most of the things. And then post-build is really helpful for both legacy, but also tracking what's the actual interaction. The downside is post-build, it's often going to be a heuristic process. And so two different tools, both may be excellent, but they may produce slightly different results.
And real quick, a specific supplier risk core of missing SBOM part, help if available. I guess they're talking about what if part of the SBOM is missing? What do you do in that case?
Well, my opinion is that part of an SBOM is better than no SBOM at all. In most cases now, 99.99% of the software you use, you have no SBOM for it. So if you can get just a partial SBOM, just one component, you'll still be one component ahead of where you were today. So, you know, so yeah, it's going to be incomplete for a long time. I'll be quite honest about that. In fact, it will never be complete in any real sense. So on the other hand, it's always useful no matter how much you have.
Well, thank you so much, all of you, for being on this panel, and thank you to the audience for attending our panel on SBOM. It's the second of our cybersecurity panel series. I hope to do more of these in future months, because I think cybersecurity is an important part of everybody's life nowadays, as computing becomes more and more prevalent in our lives. Even the power company and the very infrastructure that we rely on is mostly smart grid now. So cybersecurity is important to virtually all aspects of our lives. And thank you so much again for attending. And Alan, do you want to say anything? Alan Jones, do you want to say anything from the Richmond section?
No, just thank you to all the panelists for helping us out with the panel session, and thank you to all of the co-hosts for co-hosting this event with us.
And that's a wrap.
Okay.
Thank you.
All right,
Thank you very much.
Mm-hmm.
Thanks.